Good morning, dear students. Today we'll discuss about the softening of water by ion exchange process. So, ion exchange process, as the name itself indicates, there are two kinds of ions. Mainly, first one is a cation, and second one is a anion. So, the cations will be removed by cation exchanger, and anions will be removed by anion exchanger. So, a typical ion exchanger will consist of the two exchanger beds. First one is an cation exchanger where water is allowed to pass through and whereby all cations will be removed, and the water coming out after the cation exchanger is passed through the anion exchanger so that all the anions will be removed. So in this method of softening of water, so is done by exchanging the ions, which is usually causes the hardness of the water. And these ion exchange resins are high molecular weight polymers, cross-linked polymers, and it should have a porous structure. And the functional groups which is attached to the chains are responsible for the ion exchange properties. Now, typically, this cation or anion exchanger bed will usually consist of the polymer, either the high molecular weight polymer or maybe a cross-linked polymer with the porous structure, and some of the functional groups will be dispersed in these polymeric chains. So the resins containing acidic groups, so the resins usually the polystyrene bed will be used, and this polystyrene bed which contains an acidic dispersed groups like sulfuric acid, phosphoric acid, etc. So will act as an capable of exchanging sulfuric acid contains an H plus, so it can capable of exchanging H plus ions for the cations like sodium plus, potassium plus, calcium 2 plus, magnesium 2 plus, etc., which is present in the water. So typically, when you disperse sulfur acidic groups, the compounds containing acidic groups into a polymeric bed and used as a cation exchanger, it can exchange all the cations which is present in the water and replaces H plus into the solutions. So in the second case, where the same resin bed, that is polystyrene bed, dispersed with basic functional groups. The basic functional groups like NCH2, CH2, CH2OH, like an N-alkylated. This is what is called as an N-alkylated group, with the end group is an OH, capable of replacing this OH group when anions will come in contact with this resin. So the anionic bed, which consists of a polystyrene bed which is dispersed with the N-alkylated organic group containing OH at the end, and this OH is capable of replacing all the kind of anions like chloride ions, fluoride ions, sulfate ions, carbonate ions, etc. So when these anions will come in contact with this resin bed, it can able to capable of replacing these anions and releasing OH minus into the solution. So such exchanges are called as anion exchangers. So the ion exchange apparatus or the complete unit consists of two exchanger bed, especially one is a cation exchanger which can capable of exchanging all the cations, and the bed consists of polystyrene polymer dispersed with acidic functional groups, and anion exchanger which is capable of exchanging all the kinds of anions, which also consists of a polystyrene bed which dispersed with the basic functional groups. And typically, when you look into this figure process, now the raw water, the water which needs to get purified, the first is passed through the cation exchanger. Now, as I said, cation exchanger, which can exchange all the kinds of cations, Na plus, K plus, Ca2 plus, Mg2 plus, etc., which causes the hardness. Now, once it get exchanged with the exchanger bed, it contains an acidic groups. Acidic groups can release H plus. So easily releasable group is an H plus. H plus is released into the water, and all the cations are getting adsorbed on the surface of the exchanger bed. So the water comes after the exchanger, cation exchanger is free from all the kind of cations, and it only consists of H plus as well as anions. Now, the water which comes after the cation exchanger is passed through an anion exchanger. So, anion exchanger which will exchange only the anions but not the cations. So, anions like chloride, sulfate, carbonate, and fluoride will get exchanged with the anionic exchanger bed. And this anionic exchanger bed consists of the polystyrene polymer, which is dispersed with some basic functional groups. Now you know very well basic functional groups can able to release OH minus and exchange all the anions. So it will exchange all the anions and releases OH minus into the solution. So water which is coming from anion exchanger is free from not only cations but also anions. It consists of only H plus and OH minus, and H plus and OH minus will combine with each other and they form a water molecules, and it can be used for commercial purposes. So the a typical figure consists of the two cylinders, huge cylinders fitted with exchanger bed. First one is a cation exchanger bed, and which is attached with a dilute HCl unit, and we will come to know that how we can regenerate this exchanger bed by passing dilute HCl. This is a regeneration chamber, and the second one is fitted with an anion exchanger bed which is connected to dilute NaOH for regeneration, and water is passed through this uh, sealed drums. Once this water passes through the cation exchanger, it will get exchanged with all the cations, and anions along with H plus ions is passed through the anion exchanger. Anion exchanger will exchange all the anions and releases OH minus, and water comes out after the anion exchanger is free from cations as well as the anions. So the react so the process, when you look into the process, the water is the first passed through a cation exchange resin which removes, as I said, all the cations present in it. Cations may be of two class of cations. One may be monovalent cations, which carries only one plus charge, and divalent cations, which carries two plus charges. So monovalent like sodium plus K plus Li plus etc., and divalent like calcium 2 plus magnesium 2 plus etc. Now typically the resin bed consists of an RH. R is a polymer and H is the acidic functional group which is dispersed inside the polymer. Now RH, when water contains M plus is the monovalent cation, comes in contact with the RH. So it starts replacing H plus from the resin bed. Now it will form Rm plus, and H plus is released into the solution. Now, if it is a divalent cations, it will react with 2 moles of RH plus with M2 plus, and it will give rise to R2M2 plus, releasing 2 moles of H plus into a solution. So, typically, when water is passed through cation exchanger bed, so the exchanger bed consists of the polymer dispersed with acidic functionals like H plus. Now, monovalent cations will getting exchanged with the RH plus, releasing H plus into the solution and forming Rm plus. And divalent cations also reacts with 2 moles of RH plus, and it will give rise to R2M2 plus, releasing 2 moles of H plus into a solution. Now, this water is free from all the cations, but it contains an anions. So the where M plus is monovalent, as I said, monovalent cations like sodium plus, and M2 plus is a divalent cations like calcium 2 plus, magnesium 2 plus, etc. Now, this water is free from cations, but it's not free from anions. Now, the water is then treated by passing through an anion exchanger. Now, anion exchanger consists of basic functional group with the polymer. Let us consider basic functional group which can able to release OH minus into the solution. Now, R is the polymer. So this polymer reacts with the OH minus. So and let us consider X minus. X minus is the negatively monovalent singly negative charge anions like fluoride, chloride, etc., which will carry a one negative charge. So this X minus comes in contact with the ROH. The R is the polymer, OH is the basic functional group which is dispersed over the polymer. Now it will start exchanging with the ROH and it will form immediately RX minus. So this is RX minus will form and releasing OH minus into the solution. So the water which is comes in contact with the anion exchanger, it will start exchanging all the anions present in the water. Now, if it contains a divalent anions like SO4 2 minus, sulfate minus, CO3 2 minus, etc. So these divalent anions are also getting exchanged with the ROH. So two moles of ROH will start reacting with the X2 minus and it will form R2X2 minus releasing 2 moles of OH. So water when it is passed through a cation exchanger which can exchange only the cations but not the anions will be free from all the cations and H plus is released into the solution. Now the same water after passing through cation exchanger is passed through anion exchanger. Anion exchanger which can exchange only the anions but not the cations. All the anions are being exchanged and releasing OH minus into the solution. So water is free from all the cations as well as the anions and it contains only H plus and OH minus which is nothing but free water. So where X minus and X2 minus represents the anions, X minus is for chloride, fluoride, etc. and X2 minus for NO3 minus, SO4 2 minus, CO3 2 minus divalently charged ions. Thus the cation and anion impurities in the water which causes the hardness in the water are replaced by an equal number of H plus and OH minus ions and is being removed from the water and thus water is called as a softened water. Now this exchanger bed can be regenerated. So how these exchanger bed can be regenerated? So regeneration of the first cation exchanger bed. Now, cation exchanger bed consists of after the exchange, after the certain period of time, or when all the H plus ions are getting exchanged with the water, it consists of Rm plus. This Rm plus is passed through dilute HCl. So dilute HCl is passed through this bed continuously. Now the HCl contains an H plus and the acid, the H plus will start exchanging M plus. So it will regenerate the bed RH, which is the polymer with the dispersed with acidic functional group. RH is regenerated and it MCl. MCl is the M means the sodium chloride or calcium chloride, etc. Will be potassium chloride will be released into the water. So if it contains divalent cation, let us say R2M2 plus, it reacts with 2 moles of HCl and regenerates 2RH plus and releasing 2 moles of MCl into the solution. So cation bed will be regenerated after passing dilute HCl into the bed and it will regenerate the RH plus MCl. If it contains a divalent cation, it will react with 2 moles of HCl and releasing 2 RH plus MCl into a solution. So thus the cation exchanger bed will be regenerated and it can be used again and again for softening of water. Now, how does the anion exchanger bed will regenerate? Now, anion exchanger bed, after a certain concentration of anions getting exchanged from the bed, it consists of Rx minus, and this Rx minus is passed through dilute NaOH solution. A dilute NaOH solution is passed through the bed. Now Rx starts replacing NaOH contains an OH minus and start reacting with the OH minus present in NaOH. So R will start reacting with the OH minus and it will form ROH and plus NaX. NaX is again, if the X minus is Cl, it will be sodium chloride again, and if it contains a divalent anions, let us consider R2X2 minus, which will react with 2 moles of NaOH and it will form 2 moles of ROH and releasing 2 moles of NaX into the solution. So the advantages of this process, advantage is that the ion exchange apparatus, once it is being set up, it operates very simple to operate. Operational principles and equipments needed is very simple, and easily it can be controlled. Like the bed can be easily regenerated. So it is only a simple exchange process of cations and anions. Both acidic and alkaline water can be softened. So acidic water can be softened, even the alkaline water can also be softened, free from the impurities. Residual hardness is very low. So when the water contains the cations and anions, when it passes through both the bed, cation bed and as well as anion bed, no impurities will remain with the water. So the water comes out after the passing through both the beds is free from all the impurities. So residual hardness is very low, and it will be used for used as a boiler feed water. And the exchanger can be reused. So exchanger can be easily regenerated. So exchanger can be regenerated. Cation exchanger can be regenerated by passing dilute HCl, and the anion exchanger can also be regenerated by passing the dilute NaOH solution. So after a certain interval of time, when the water passes through the both the bed, exchanger bed can be easily regenerated. And raw material is very cheap, and the only the polystyrene bed with a certain percentage of acidic functional and basic functional groups are dispersed. So these are some of the advantages of the softening of water.